Y'all can't handle this.
Team X, Team X.
Marysville, Maryland, boy. We out here spitting some math facts, boy.
It's everyday, bro, with the integral flow. Copped a 5 on the exam, yeah, and never done before. Passed all the competition, man, Calc BC is next. Man, I'm popping all these checks, got this brand new flex. And I have an amazing teacher, and I'm flowing with the nose. This is Team X, and this how integration goes. If you wanna go and find the volume of a solid, there's a washer, disk, and shell method. I already called it. Once you're given some functions, find where your bounds are placed. If the solid revolves on the x-axis, your bound should be x values, you got it ace. If the solid revolves on the y-axis, guess what your bound should be? Y digits. Don't forget the formulas, remember just because 2 pi r and pi r squared. Y'all best be prepared, we cannot be outdone. Yeah, Calc is number 1.
It's everyday, bro. It's everyday, bro. It's everyday, bro, with that integral flow.
You know it's top bottom when it's going round the x. You know it's right left when it's all about the y. If a part of the graph doesn't fully touch an axis, just find an inverse function to avoid a malfunction. Now don't forget the most important rule that reigns. Free space indicates the washer method case. The top function to the axis represents big R, while the bottom function to the axis represents little r. Subtract the two functions and don't forget to square. Now you've found the volume of a fancy MacBook Air. The cross-section method is somewhat similar. It's the top minus bottom or the right minus left. Just sub it in a triangle, in a square, or a star. Root 3/4 times s is squared would give you the volume of an equilateral. Now you know how to integrate like a boss. Go tell your teacher it was all because of us.
It's everyday, bro. It's everyday, bro. It's everyday.
Hold up. Can you explain this problem? Determine the volume of the solid formed when the region bounded by y is equal to x squared and y is equal to 4 is rotated around the line y is equal to 4.
First, when we draw our two functions, our y equals x squared will look like this because it's a parabola, and our y equals 4 line will be cut horizontally across. We will be finding the volume of this area because it's bounded by our two functions and is located in the first quadrant. Since there is no space between the area and the line it's rotating around, we will be using the disk method. The formula for disk method is v equals pi times the integral of the radius of our solid squared dx. Alright, so the bounds of the integral will be from where our area starts to the intersection point of the two functions. In this case, our bounds will be from 0 to 2 because 2 is the x value of the intersection point of our two functions. Because our solid is rotating around the horizontal line, our radius will be the top minus bottom function. In this case, that is 4 minus x squared. And don't forget to square that afterwards. So once you type this into our calculator, it will be pi times the integral from 0 to 2. 4 minus x squared dx. So that makes the volume of our solid 53.617.
Dance battle?
Yeah. Go.